Blind hole features in injection molds can be susceptible to deformation from suction during ejection, especially with short cycle times and wall thicknesses that are too thick or holes that are too deep. This is because the blind feature creates a trapped volume of air that is evacuated when the mold opens, potentially causing the plastic to pull away from the mold walls and deform the blind hole. Also, it can be caused by several factors, including insufficient cooling time and uneven shrinkage. To address this, solutions involve optimizing cooling systems, extending cooling times, and potentially redesigning the molded part and the mold to improve material flow and reduce shrinkage. This is why design for manufacturing, DFM, is very critical in the early stage of the part design and mold design. Blind holes and deep pockets require special attention to ensure proper venting. Blind holes, which don't open to the outside, can trap air during the molding process, leading to defects. Similarly, deep pockets can also trap air and gases, potentially causing issues like burn marks, incomplete filling, and poor surface finish. Deep blind holes. Deep blind holes require longer core pins, which can be more prone to deflection and deformation and eventually break under pressure. And it will be too late by the time you or the customer realize that the blind hole is filled with plastic. Core pins or inserts that are too long and thin in an injection molding process can indeed break. This is because they become too slender to withstand the high pressure forces involved in the injection molding process, as well as the thermal stress from cooling cycles. Uneven forces and misalignment. If the core pin or insert is too long and thin, it can be easily deflected from its intended position during the molding process. This deflection can lead to uneven forces being applied to the pin, which can cause it to fail. Why it happens? Trapped air. Blind holes, especially deep ones, trap air during the injection process. This trapped air needs to escape as the plastic cools and contracts. Vacuum effect. When the mold opens, the trapped air is rapidly evacuated, creating a vacuum effect. This vacuum can pull the plastic away from the mold wall, especially in thin-walled areas or near the blind hole feature. Short cycle times. Shorter cycle times mean less time for the plastic to cool and solidify, further exacerbating the vacuum effect and the potential for deformation. How to address it? Ventilation. Ensure adequate ventilation in the mold to allow the trapped air to escape during filling. This might involve adding vents or increasing vent size. Draft angles. Use proper draft angles on the mold, especially on the blind hole feature, to promote ease of ejection and minimize the pulling force. Mold design. Consider the blind hole geometry. Deep blind holes or features may be more prone to deformation. Adjust the design to minimize the volume of trapped air or make the feature less deep. Cycle time. If possible, increase the cycle time to allow for more complete cooling and solidification of the plastic before ejection. Ejection system. Use a strong and efficient ejection system that can quickly and effectively remove the part without causing damage or deformation. Dimensional rules for hole depths. The common holes on plastic parts can be roughly divided into three types: blind holes, through holes, and stepped holes. Through holes are easier to manufacture than blind holes because the cores can be distributed on both sides of the molds, and the through hole depths can be appropriately increased. If the hole is too deep, the stepped hole method can be used instead in molding. Add radii to the end and to the top of the hole whenever possible. Radii help distribute stress more evenly, preventing stress concentration points that can lead to failure. Dimensional rules. 1. For blind holes, if the diameter is less than 5 mm, then the maximum height or depth of the hole should be less than or equal to 2 times the diameter. 2. For blind holes, if the diameter is greater than 5 mm, then the height or depth of the hole should be greater than or equal to 3 times the diameter. 3. For through holes, if the diameter is less than 5 mm, then the maximum height should be less than or equal to 4 times the diameter. For 4-through holes, if the diameter is greater than 5 mm, then the height should be greater than or equal to 6 times the diameter. When designing deep holes for injection molding, it's crucial to consider several factors to ensure proper filling, avoid defects, and maintain structural integrity. Key design criteria include limiting the depth to diameter ratio, especially for blind holes, ensuring uniform wall thickness, and incorporating draft angles and radii where necessary. Critical point, depth and diameter, material flow, ventilation, draft angles, add radii. Hole placement. Keep holes at least 1 diameter away from edges and other holes to maintain structural integrity. Align holes with the direction of plastic flow for efficient filling. Avoid placing holes in high-stress areas. Ejector sleeve ejector pins can be used to help vent blind holes. These pins, which are a hollow cylinder with a fixed center pin, can create a path for air to escape as molten plastic fills the mold, preventing the trapping of gases and ensuring proper filling. Ejector sleeves and pins. An ejector sleeve is a hollow cylinder that fits around a fixed center pin, the ejector pin. Venting. When the mold is filled, the sleeve and pin can be designed to allow air to escape from the blind hole, preventing trapped air from causing defects in the molded part. Deep features. Ejector sleeves are particularly useful in molds with deep or intricate features where traditional venting methods might not be effective. Ejection. The ejector sleeve also plays a crucial role in ejecting the molded part from the mold by sliding over the center pin. Advantages. Using ejector sleeves for venting can improve the quality of the molded part by preventing air trapping and ensuring proper filling of the cavity.
给我一个安静的角落，避开所有眼光的探索，寂寞是我唯一的借口。经过多年刻意的漂泊，面对无数陌生的探索，寂寞是我唯一的借口。为什么？经过多年以后，所有的过与错不能淡薄。为什么经过多年以后，得失的过程如此冷漠？并不是我故意冷漠，也不是要让自己孤独，只是心里话该向谁诉说。我只想要简单的拥有一片小小真实的天空，不要再有飘零的失落。为什么多年以后，所有的爱恨不能淡薄？为什么经过多年以后，风干的伤口心痛依旧？ 这些日子就这样经过，今天不再是昨天的我，也许明天要面对的更多。每当夜深人静的时候，触摸伤痕漫步的双手，任着痛挣脱内心的枷锁。为什么经过多年以后，所有的过错不能当我？为什么经过多年以后，得失的过程如此冷漠？为什么解脱？为什么经过多年以后，风干的伤口心痛依旧，得失的过程如此冷漠？好，谢谢一首来自姜育恒的一首经典老歌，一首多年以后。